What does the inverse of a relation mean? Naturally, it's the inverse process of what we define by a relation. Let us look at the details. So, if we are dealing with a relation from set A to set B, then the inverse, which is denoted by r raised to minus 1, and not the point that r raised to minus 1 isn't representing a mathematical operation. It is not equal to 1 by r. So that's a very important point, which we have to note that r raised to minus 1 is not equal to 1. So it doesn't mean like that. That's not a meaning here. Of course, that's a meaning in when we are writing other equations, but in this particular case, that's not the meaning. So r raised to minus 1 is just an indication for an for the inverse of a relation. Uh, if it simply means that we are dealing with a relation in the other order, or if that is from B to A. Now the key point is that how do we represent it in the set builder form? Naturally, we know that if we are dealing with a Cartesian product of set A with set B, then naturally the order of the elements would be A and B, but for an inverse relation, it would be the other way around, that's BA. So r raised to minus 1 is BA such that AB is an element. Now, the key point is that only if the ordered pair AB is an element of the relation, then you will be getting the inverse relation. So that's the important point. And AB is a element of the relation, and in only if BA is an element of R raised to minus 1 or the inverse relation. So it simply means that an inverse relation is possible only if the order in which the elements are occurring is reversed, and that reversal is possible only if the original order, that is A and B, is existing. So that's the key point. Now the interesting corollary of this particular meaning is that we know that the domain consists of the first elements or the first elements of the ordered pairs, and naturally when we are taking an inverse relation, it's the domain which becomes the range, and that is also the case with the range. I mean, that's the range of a normal relation. Normal relation in the sense that the range which we get from a Cartesian product of set A with set B would actually become the domain of that particular relation in inverse. To clear the point and to get the right idea, let us look at a simple case of set A having elements 6, 7, 8, 9, and B having the elements C, D, F, and we are having a relation having which consists of 4 ordered pairs, that is 6C, 8D, 8F, and 9C. Now, naturally, the domain is the elements A as that's the elements which form part of the ordered pair coming from set A, and here in this case, it consists of elements 6, 8, 9, and now the interesting thing is that of course the range would be C, D, F. So now the range of the inverse function would be the domain, that is 6, 8, 9, and the domain of the inverse function, sorry, the domain of the inverse relation would be the range of the straight relation, that is C, D, and F. Thank you.